So for lesson 11.1, what you're going to do is you are going to go to the book and you're going to either read the lesson or you're going to go to the glossary and write down definitions of each of these terms here. What I'm going to do right now is do some table of common polyhedra as well as go over the example problems in a second. As I'm going over these, it is really helpful to see them kind of like in front of you in real life. So hopefully this translates on the video, but I'll also bring these into our in-person time. So the first one, you might recognize this from our chapter 8 as a triangular pyramid because it has one triangular base and 3 triangular lateral faces, which might be difficult to interpret from this two-dimensional picture, but I'm going to show you this die that I have right here. This is a triangular pyramid. It also is a regular polyhedra because all of the faces are congruent. They're all equilateral triangles. This is used for role-playing games and things because of the way the die is numbered. But for our purpose here, we're not going to call it a triangular pyramid. We're going to call it a tetrahedron because it has 4 faces. In this case, we don't use quad as our prefix for 4. We're using tetra. This next one, again, it has 2 triangular bases and it has 3 lateral faces. And you might, again, call it a triangular prism, but its polyhedra name is a pentahedron. Just like a pentagon has 5 sides, a pentahedron has 5 faces. Same thing with this one. This is a hexahedron. This one here is an heptahedron. Hepta meaning 7. This one is an octahedron. I'm going to show you another octahedron. This one happens to be a hexagonal prism, but here is another example of an octahedron. There it is. This one's a little bit bigger. This is 2 rectangular pyramids joined together. So you can see this has 8 faces. So this is another version of an octahedron. So these can look different depending on how the faces are arranged and what are made of the faces. This is also a regular polyhedra because all of the faces are congruent. They're still equilateral triangles, just like this one, except these ones are arranged to form an 8-faced figure, whereas this only makes a 4-faced figure. This next one, nonahedron. And again, decahedron. I do happen to have a decahedron here. It looks like this. It's slightly different than the one that I have here, but it has 5 faces, and then 5 more faces. It doesn't have a 10, instead it has a 0. I hope that you can see the way this is put together. 11 is called an undecahedron. An 11-sided polygon is called an undecagon. And then this 12-faced polyhedron is called a dodecahedron. And I happen to have a dodecahedron here. Here's like a nice, cute little baby one. You can see all the pentagons. And here's a bigger one here. Some of these are called Platonic solids because they are all of the different regular polyhedra. And Plato believed that these particular solids represented elements of the world. So you can kind of Google that if you want. Another really famous polyhedra is called an icosahedron. This is a 20-faced polyhedra. And again, here is like the slightly larger version. So after you go through all of this, you can pause this video, or if you're ready, you can just keep rolling and we'll go over the examples. So we have two polyhedra here. The first one, we're going to name the bases of the prism. So this is a prism, and our bases are our triangles, right? So triangle TSU, and then triangle PRQ. Name all of the lateral faces. So there are 3 lateral faces. There's this one here, there's this one here, and then there's the one in the back. All right, and now this is an oblique solid because it is not perpendicular. The height is not the same as the axis of going between the centers of the bases. So the lateral faces are quadrilaterals, so we're just going to name them by the 4 vertices. So TUQP, TSRP, and then USRQ. Again, these can be named in different ways depending on the order that you use. The lateral edges, there's 3 lateral edges. TP, and these are segments, so we're going to use our segment notation, UQ, and then segment SR. The height of this prism is 6. This is the slant height. This is the actual height. And now we're going to go to the pyramid. The base of the pyramid is this hexagon down here. So we can call it GYPTAN. The vertex is this point at the top, point E. There are 5 lateral edges, segment EG, segment EY. You see what the book did here? Pyramids, Egypt. Yeah. Segment EN is kind of hard to see. It's in the back. It almost looks like it's like overlaying with segment EY. Segment EA is kind of the same. Then segment EP is this one in the front. And then finally segment ET. And then again, the height of our prism, our pyramid is 13. 15 is the slant height. Actually, 15 might not even be the slant height. It's like the length of the edge because the slant height is perpendicular. So probably not even that. So height is 13. So this is our introduction to solids, and we will be working the rest of this unit with solids, specifically in the area of volume. So great job with this.